All right, with this lesson, we're going to be focusing on some properties of parallelograms. In particular, there are 4 pieces of knowledge about parallelograms that we expect you to know. You may be familiar with some of them, you may not. But the expectation for you today is that you learn these 4 facts, and then you use them to solve problems, and you use them to prove theorems. In particular, we're going to start off and note just a basic terminology. Whenever we talk about opposites, of course, opposite sides would be top and bottom, left and right. That part's easy. But when we're discussing opposite angles, and where's my parallelogram? If we're discussing this angle, which one is opposite that? Opposites don't share sides, and so the opposite angle would be this one over here. The other pair of opposite angles would be these ones. We have opposite sides, top and bottom, opposite sides, left and right. But when we talk about opposite angles in a parallelogram, we're referring to the ones that are opposite diagonals. Not consecutive diagonals, opposite diagonals. And of course, here's something that I bet you already know. What is a parallelogram? A parallelogram is a quadrilateral that has exactly 2 pairs of parallel sides. With the way that they're typically drawn, we would have the top and bottom be parallel, left and right be parallel. Of course, we know that it could be a rotated shape, so it's more like slanted. But we do get our 2 pieces, parallel and parallel. This is, of course, significant for us because back in the last semester, we spent a significant amount of time working with parallels. And we saw a ton of times that you could draw in transversals, and that would give you corresponding angles congruent. It gives you same side interior angles are supplementary. When you've got a set of parallels, alternate interior are congruent, alternate exterior are congruent. All of those facts that we had for parallels before, they're still true. And we will still use them in these shapes because we have a set of parallel lines or a set of parallel segments being cut by a transversal, so we've got all that same information. In particular, one of the things that you should immediately observe, these 2 angles are same side interior. Same side interior angles are supplementary. So we know that those would add up to 180. And additionally, we'd be able to look at it and say, that one and that one. We'll have another pair of parallels being cut by a transversal. And so now we have same side interior being supplementary. Again, when we're looking at these, there are several things that we should be able to look at and still take advantage of our pieces. So keep in mind that we're going to use a lot of those parallel facts. First thing about parallelograms that we expect you to know. And unfortunately, these things don't really have a name to them, so it's not like you can say, this is the parallelogram theorem. They're just expected you to know, and when we reference them, we're going to generally use the symbolic logic. But first of all, if you know that it's already a parallelogram, your opposite sides will be congruent. That is, those parallel sides. Your top and bottom are not only parallel, they have to be the same length also. The left and right hand side are not just parallel, they are also the same length. Collectively, this fact we'll refer to by its symbolic logic. A parallelogram implies opposite sides are congruent. The other 3 facts that you're expected to know, so the final 3 out of the 4, are posted right here. Additionally, we started the video by emphasizing the opposite angles and the opposite sides. Well, there was a reason for it. We emphasize opposite sides because opposite sides are congruent. We emphasize opposite angles because, again, opposite angles have to be congruent. This angle and that one will be the same size. Well, why does that have to be true? We won't go through the full details, in part because some of the details are the proofs that you're expected to do within your homework. But the basic idea is you can draw a diagonal. When you draw on the diagonal, what will you know is true about those two triangles? Well, since opposite sides are the same, that's one pair of congruent sides, two pairs of congruent sides, three pairs of congruent sides. They're going to be congruent triangles. And because they are congruent triangles, matching angles, corresponding angles have to be the same. Done. And there are other ways to get that congruence as well. But still, emphasizing opposite angles have to be congruent. A little bit earlier, we observed that consecutive angles, because they are same side interior angles, consecutive angles have to be supplementary. And of course, we know that since they're supplementary, we can create equations saying angle plus angle equals 180, as long as they're same side interior. Last one actually comes into play, and a little bit tougher to prove. Still a piece within your homework with a guided proof. If you draw in both the diagonals, when you draw in both diagonals, they bisect each other. And this is a really, really helpful one because it tells us that the left-hand side will be the same as the right-hand side. It tells us for the other diagonal, the left-hand side is the same as the right-hand side. And of course, please note that this is not telling us that the two diagonals are the same length. We can just look at it and see clearly one diagonal is short, one diagonal is long. This is saying that they cut each other in half. These are the four facts which you are expected within your homework. You're going to prove several of these things are true with a guided proof. And throughout the other pieces of your work, you're expected to apply these things wherever they are appropriate. For instance, which one of these seems appropriate for a problem? In parallelogram CDEF, please remember when we put down the order, CDEF tells us the order in which the points connect to each other. CDEF looping back to C. For this particular problem, it's not like massively important, but it is a fact that we will use. So, DE is 74 millimeters. DG is 31 millimeters. The measure of angle F to C to D is 42. How big is CF? Well, which one of our facts are relevant? Are we using information about opposite sides? Are we using information about opposite angles, consecutive angles, or diagonals? Everything you're doing is going to boil down to one of those four facts. So which one is appropriate? Well, since this is a side, it makes sense that we should consider sides. The opposite sides will be the same. That's 74 millimeters. Done. And for this particular problem, we didn't need to know the diagonal because we weren't searching for information about the diagonal. We didn't need to know anything about the angle because we weren't searching for information about the angles. you'll have to recognize which one of the properties is being used for any particular problem and simply recognize these things are the same, or these things add up to 180. What about this problem? What of course are we searching for? LM is 28 inches. LN is 26 inches. The measure of angle LKN is 74 degrees. How big is KN? This is the exact same problem. Serious. Exact same problem. It's once again asking us for an opposite side. It's just being applied in the context of, hey, look, it's a basketball hoop. But it's still the same thing, 28 inches. Done. And you stop and look at it. That looks like it's a complicated problem because there's a lot of information there. But as long as you recognize the properties, a lot of the work is very simple, very direct. What about here? WXYZ is a parallelogram. Find YZ. Well, what is our relationships? What relationship are we going to use? Well, here we have our third problem where if we're searching for YZ, that's again a side. And so opposite sides are congruent. That means opposite side lengths are equal. That's the relationship we need to use. We need to recognize those are equal to each other. And the geometry here is done. We've built our equation based on the relationship. Now we just have to solve it. We'll note that if you subtracted off the 6 from both sides, you get 2a. If you added the 4 to both sides, you get 14. And when you divide by 2, a is equal to 7. That's still not done because the directions didn't say find the value of a. Our directions told us find the length yz, so we'll plug it right back in. 8a minus 4. 56 minus 4 gives us 52. And we're done. Again, pay attention to the directions because the thing that you were asked to find is going to help you identify which relationship you're looking for. For instance, what if instead of saying find yz, we instead said that? How would the problem be different? Exact same picture. But if we're looking for these pieces, if we're searching for angle W, well, there are two angle relationships we have. We have a relationship for opposite angles are the same. Consecutive angles are supplementary. Do we have opposite angles? The opposite angle is y, and so we know W and y will be the same size. But since we don't know a dang thing about y, we can't create an equation saying they're equal when we are missing the other side of the equal. But we can recognize W and Z as consecutive, so those are supplementary. We can create our equation there saying angle W plus angle Z has to be 180 degrees. And you'll notice then that it's a different equation based on a different relationship, but the process is still the same. Recognize the fact that you're supposed to recognize, create the equation, and solve it. Rushing through this one, 18 plus 9 would give us 27b. 11, negative 11 plus 2 would be minus 9. And adding 9 would give us 27b equals 189. And dividing out by 27, 189 divided by 27 equals 7. Since b is equal to 7, we would take 18 times 7. That's 70 plus 56, 126. 126 subtract 11 gives us 115 degrees. And we're done. And yeah, I know I rushed through that a bit quickly, but you've demonstrated a number of times that you don't have a problem with that. So, third one. What equation could you create based on this relationship? What equation can you create based on what you're being asked to find? We're being asked to locate JG. JG is a part of a diagonal. And we know that the diagonals bisect each other. So the relationship you're supposed to recognize here, those two things are the same. 3w is the same as w plus 8. That will lead you to w equals 4. And 4 plus 8 gives you an answer of 12. You're done. Please keep in mind, I expect to see the work written out like in the red. I expect to see the equation. I expect to see some work solving the equation. For a simple equation like this, yes, I'm very aware that you can solve them in your head. For something that's a little bit more complex, maybe you'll need to write down a step or two, but I expect to see the work. Okay. This particular problem, I'm not going to need to create an equation. We have three vertices of parallelogram JKLM. 3, negative 8, negative 2, 2, 2, 6. Remember how I said earlier that the coordinates, the order matters? J, K, L, M. So we're saying J, K, L, M needs to be over here somewhere so that we'd be able to create a parallelogram. Obviously, that's not a parallelogram. So where should the point be? Should it be here? That looks better, but is that the correct spot? Where should this point M be located so that it actually does create a parallelogram? Perhaps the quickest way to get this one is to take advantage of some properties that we had back. Remember when we were working on coordinate proof? We mentioned that if things are parallel, they have the same slope. So what we need to recognize then is, since this is supposed to be a parallelogram, these things have to have the same slope. In order to ensure that they had the same slope, we had a really quick shortcut for it. Just count them. How far up, how far over. For this one, we're looking at 1, 2, 3, up 4. 1, 2, 3, right 4. We'll do the exact same thing. To maintain the parallel sides, 1, 2, 3, 4. 1, 2, 3, 4. That's where M is supposed to be. So, what are the coordinates for that vertex M? That's 7 to the right. Down 4. Done. And this allows us to identify with certainty then That is our parallelogram. Okay, last problem for the lesson. And of course, it's a proof. Prove that triangle AEB is congruent to triangle CED. So we are trying to explain why are these two triangles congruent to each other. In terms of movement, it looks like a 180-degree rotation. But since we don't have coordinates, we can't be certain that it actually does line up perfectly. So we'll start by noting we're given an important piece of information. We've got a parallelogram. And we now have 4 facts about parallelograms that we know. In particular, we know the left side is going to be congruent to the right side. AB is congruent to CD because parallelograms tell you opposite sides are congruent. That's one. But we also know a parallelogram tells you diagonals bisect each other. And because diagonals bisect each other, those two pieces have to be the same. BE has to be the same as DE, as the left-right piece of the diagonal. And of course, we've also got the other diagonal, AE and CE. Well, of course, that then goes through and tells us that the triangles are congruent. Using our tools from the last unit, side pair number 1, side pair number 2, side pair number 3. Because of side, 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 we are absolutely certain those triangles are congruent. Done. Of course, this is not the only way we could have done it. If we wanted to instead, a different way that we could have solved this problem, we could have used vertical angles and set up side angle side. Done that way. With each one of your proofs, there is more than one correct way to do it. But regardless of which strategy you apply, you will need to go through, you will have to know, you will have to apply, and in many problems you have to recognize which properties you can use. You are absolutely expected to understand that opposite sides of a parallelogram are the same. You absolutely must know that the opposite diagonals, that diagonals cut each other in half. You have to know the same side interior or consecutive interiors make supplementary. You have to know opposite angles are congruent.